Hello, good afternoon, everyone. Today we are considering another topic titled the optical instruments. We use devices made from lenses and other optical instruments in our daily activities. We put on a pair of eyeglasses or contact lenses, take photographs, look at the sky through the telescope. In our modern day tech cars, we have reverse cameras equipped with a camera. On our phones, we have camera. The list is almost endless. However, before we proceed, here is a quick list of our learning outcomes. First is that at the end of this lesson, you should be able to list 6 common optical instruments. Secondly, you should be able to explain the physics behind the eye as an optical instrument, because our attention is to focus on eye for today's class as an optical instrument. Also, we should be able to list at least 4 common eye defects and how it can be corrected. But before we delve into the class fully today, a quick recap of our previous lessons. What is a lens? A lens is simply a piece of transparent material such as glass, plastic, quartz, fused silica, or liquid with one or more curved surfaces in which the extent and nature of the curvature of its surface determines the effect it has on the beam of light. And you will recall again that we said we have 2 types of lenses. It can be converging lens, which is actually thicker at the center than at the edges. It's also known as convex lens, and it could be a diverging lens, which is thicker at the edges than at the center. It is also known as a concave lens. And also, we defined what the power of a lens is, that it is the reciprocal of the focal length, meaning that it is the measure of its ability to change the curvature of the wavefront at the lens. Also, a quick reminder on the law that guides the behavior of light as it passes through a lens, which is actually light moving from a medium through another medium. The law is the law of refraction, and the first law of refraction says that the incident ray, the refracted ray, and the normal to the interface of the 2 transparent media at the point of incidence all lie in the same plane. And the second law states that the ratio of the sine of angle of incidence to the sine of angle of refraction is a constant. Straight to the business of today. Common optical instrument. There are many optical instruments that will come in contact in our daily activities and in nature. The common ones are the eye, the camera, the magnifier, the simple microscope, the compound microscope, and the refracting telescope. I know that most of us are familiar with the magnifier because we have used it even in our elementary classes, where we used to see an enlarged image of an object. And we have also worked with various types of camera in the time past, and even on our phone. So we are already familiar with this. So our attention today will be focused on the eye. The reason for the eye, you will learn in this particular class of today. The eye, the human eye, is about the most important of all the optical instruments in nature, because it helps us to utilize other optical instruments. The use of the optical instrument depends on our eyes, and that is why it is regarded as the most important optical instrument, and it occurs in nature. The adult human eye is about 2.5 centimeters in diameter, meaning that the external portion of the eye that we see when we look at ourselves in the mirror is relatively small compared to the dimension or the size of the eyes. Its near spherical shape is maintained by a pressure of fluid within it. As you can see, the schematic of the eye, within this region is a fluid maintained by pressure within it, and within this section too is a fluid called the aqueous humor, and here is a fluid called the vitreous humor. The eye is a sense organ and part of the sensory nervous system. In all respects, without missing what the eye is a physiological wonder. What matters to us, however, in this studies session, in this class, is to understand the physics of various parts of the eye. Parts of the eye. The first part of the eye we'll consider is the cornea, which is the curved transparent membrane at the front of the eye. In fact, when you are looking at someone, the cornea is what you see where light enters into the eye and where most refraction takes place. It transmits and focuses light into the eye to make sure our eye records clear images. Next, as we move inside, is the iris. It is the colored part of our eyes, and it is a muscular diaphragm that controls the pupil size. It's actually like a curtain that controls the amount of light that enters a room. The iris regulates the amount of light entering the eye by dilating the pupil. The pupil is the aperture, which we will look at, which we will consider as our next point. So in low light conditions and contracting the pupil under condition of bright light. Pupil. It is a variable aperture or simply a hole through which light passes. The iris regulates the amount of light entering the eye by dilating the pupil in low light conditions and contracting the pupil under conditions of bright light. It is important for us to note that its diameter can be changed from 3 millimeters to about 8 millimeters depending on the intensity of light. Oftentimes, if you leave a room that is relatively dark and you move out to a region of maybe bright light, maybe you move out on a day where you have high level of brightness of the sun, you feel a sharp sensation, which is actually the adjustment of the iris, controlling the amount of light entering the eye for you to have a very clear image. The eye lens is the next part to the pupil. The lens is like a capsule that is at the center and progressively softer at the outer portions. The eye lens is held in position by the ciliary muscle. The ciliary muscle helps in changing the curvature of the focal length of the eye in order to focus the image on the retina. I've shown you on the schematic what the vitreous humor is, and it is the fluid that fills the space between the retina and the eye lens. The retina is very, very important. It is the sensory membrane lying at the back of your eye. It is composed of several layers of cells called photoreceptors. The photoreceptors are millions of light sensitive receptors, which can be a rod or a cone. The rod is actually sensitive to black and white colors, and the cones are sensitive to the various spectrums of color of light. When stimulated by light, these structures send impulses to the brain via the optic nerve, converting them to the conscious view of the world around us. The blind spot is the spot at which the optic nerve enters the eye and is insensitive to light, hence the name. Now, we'll quickly consider some keywords that we use before we discuss how the eye focuses on object, which is the physics of the operation of the human eye. So, the accommodation of the eye. It is the process by which the ciliary muscle changes the focal length of the eye lens in order to focus distant or near objects clearly on the retina. And we'll see the details of this next on the next slide. The power of accommodation is its ability, that is the ability of the eye to focus objects lying at different distances. Worthy of note is the fact that as we age, the power of accommodation declines. How does the eye focus at varying distances? When the ciliary muscles are relaxed, the eye lens becomes thin, and thus the focal length increases and we see distant objects clearly. However, when the ciliary muscle contracts, the curvature of the lens increases and the lens becomes thick. When it contracts, making the lens to be thick, and the focal length decreases and we see nearby objects. Therefore, it is the adjustment of the focal length of the eye lens which enables us to focus on objects situated at different distances. Very important for you to know. The adjustment of the focal length of the eyes enables us to focus on objects situated at different distances. So, a quick summary of on accommodation. When objects are at a far distance, the ciliary muscle relax, suspensory ligament tighten, which is connected to the ciliary muscle, and the lens shape becomes thinner, meaning that the amount of light refracted is less. On the other hand, when the object is near, the ciliary muscle contract, making the ciliary suspensory ligament to slacken. Thus, the lens shape becomes rounder due to the contraction of the ciliary muscle, thereby allowing more light to be refracted through the eyes. Another key word to know, aside from accommodation, is near point or least distance of vision. And the near point is the point nearest to the eye at which an object is visible distinctly. For a normal eye, the least distance of distinct vision is about 25 centimeters, but you should know that it varies with age of a person. For instance, in infants, it's about 5 to 8 centimeters. Far point is the maximum distance up to which the normal eye can see things clearly. It is infinity for a normal eye. So, and the range of vision is the distance between the near point and the far point of vision. Now we consider the defects of vision. Now that you know the parts of the eye and how the eye focuses on objects at varying distances. The first defect we'll consider is the myopia, also known as short sight or short-sightedness. In this case, the eye can see near objects clearly, but not distant objects. What happens is this: the eye cannot focus on distant object because the eyeball is too long or the eye lens is being too strong. Thereby, the image of distant object is usually formed in front of the retina, and these can be corrected by a type of lens that can cause light to diverge, to make the object, the image, to be received on the retina. And this kind of lens is called the concave lens. Long-sightedness or hyperopia. In this case, the eye can see distant object clearly, but not near ones. The eye is too long, is too short, or the lens, either the eye is too short or the lens is too weak. The image of a near object is formed behind the retina. So to correct this, you need something that can converge the ray of light to draw the image formed behind the retina inwards to be focused on the retina. And this type of lens is a converging lens, also known as a convex lens. Another eye defect is presbyopia, which is sometimes regarded as hyperopia due to age. And this is a defect that occurs as you age. The eye cannot focus on objects up close. The eye cannot focus light directly on the retina due to the hardening of the natural lens, and the lens reduces its power of accommodation, thus limiting its flexibility. So aging also affects muscle fibers around the eyes, making it difficult to focus on object close. So these are the two major causes of presbyopia. And to correct this, we use a convex lens. Astigmatism is another common defect, and this can occur within any age bracket, might be in children or as middle ages or as at old age. This often occurs when the surface of the cornea is distorted or slightly elongated in the middle, meaning that a condition can arise when either the cornea or the lens or both is not perfectly symmetric, and in this case light passing through the eye lens is not focused at one point. It might be multiple points. One point might be behind the retina, one point might be on the retina or even in front of the retina, and this multiple point causes objects to appear blurry. One of the major causes of this, especially in children or infants, is constant rubbing of the eyes, making the surface of the cornea to be distorted. So this can be corrected with lenses having different curvatures in two mutually perpendicular directions. This type of lens is commonly known as a cylindrical lens. A quick summary of what we have learned today. We have been able to list common optical instruments, which are the eye, the camera, the magnifier, the simple microscope, the compound microscope, and the refracting telescope. And also we discussed the various parts of the human eye, and we mentioned the cornea, the iris, the lens, the retina, which are the key parts of the human eye. And we also said common eye defects can be corrected by either a diverging eyeglass or a converging lens, depending on the type of defect that we can use. That a diverging lens are used to correct defects of a nearsighted eye or myopia, which cannot focus well on distant objects, and we can use a converging lens to correct defect in which the eye cannot focus on objects up close. So for further reading, you can use these literatures. Thank you for listening.